Welcome to the Astro. So, in this Python for astronomy tutorial, you are going to learn about a very important concept in astronomy called BPT diagram or a diagnostic for galaxies. So, basically, this BPT diagrams is capable to demonstrate that how galaxies can be distinguished uh, from normal AGN to star-forming galaxies and the composites on the basis of their different line flux uh, ratios. So here you can see that we have a simple BPT diagram of the manga sample galaxies. So here you can see that on x-axis you have a log of into flux versus internal flux ratio, and on y-axis we have O3 flux by H beta flux ratio. Okay, so we'll use this ratio and we'll put some constraint to divide uh, this region into two regions, AGN or composites. Okay, so you can see here the green line and black dotted lines having some equations in terms of your x-axis and y-axis. So these like lines will be used to separate star-forming galaxies to composite to AGNs on the basis of their line flux ratio. So these tools provide you to make differentiation whether a galaxy contains AGN or not. I mean, a galaxy is like only a star-forming galaxy. It has only AGN, or it's like a star-forming and AGN both. So this will decide through this plot. We have understood that what is this PPT plot and what it is used for. So now our job is to uh, visualize this plot through the data available on the website. So I will be using this download option from a website called SESA Telescope. It's a Sloan Digital ASCII survey, and from there we have to download these flux values. So we have the N2 flux, H alpha flux, O3 flux, and H beta flux. So we have to download from the website. Okay, to make this BPT plot. So let's download the data from the website first. So I will go to the browser and I will use my data from DR16 data HSS. So type here uh, HDSS DR16. So open it and go to here uh, Sky Server, the first link, and go to the SQL. Okay, go to the SQL search. So here will be downloading the data from the query, SQL query. Okay, so I will okay, so before that I will go to the schema browser and I will open it and I will type here gal aspect and go. So is a table. So if you go to this gal aspect line table, so there is all fluxes have been given. Okay, you can see here O2 flux is given, its beta is there, its delta is there. So every fluxes will be obtaining. Okay, and also error in that. So okay, so first I will obtain the H beta flux. So I will copy. Okay, so for before that I will use a command called from this table name. So table name is girl aspect line. So I will just copy it here and from girl aspect line as G. Okay, and then I will uh, select some data. So select top 10 for time being to show, and then I will choose the line. Okay, so for choosing line, just type here, go here, and you want is beta, right? So is beta. So you want here is beta. Okay, so here you can see that you have your is beta flux. Okay, so I will just copy it, and also the this both quantity should be used. Okay, flux unit is in this unit. So I will just copy it, and I will put in the g dot flux, and also I will get the flux error. Okay, so just add error. Now run the query. So here you can see that you have got here h beta flux and h beta flux error. Okay, so see, on a similar footing we will also get the more fluxes. So g dot you need to obtain your, so you need to your, you have S beta and then O3. Okay, so go to O3. So here is your O3 fluxes. So just copy the keyword and flux, and also you want to obtain flux error. Okay, so flux error. Now run it. Okay, submit the query. Okay, so you got here flux error also. Okay, so like add more. Now you want to obtain your into fluxes or inch alpha. So we have inch alpha. So I will get inch alpha flux here. G dot inch alpha, and I will also obtain error in that. Now I need to obtain the into fluxes. Okay, so into 6584. So we just put here. And then the error in that, right? Now run the, okay, so you can see here you have H beta flux error, O3 flux error, inch flux error, and into flux error. Okay, so you can see that we have selected only 10 uh, rows. Okay, so for that I will just remove top 10, and I will download the whole catalog. Okay, so I will just put in the feeds table that I want in a feeds format, and I will submit the, so I will submit here. So you can see it's running. So our data will be downloaded soon. So we need to wait for some time. Okay, so here you can see that your data is downloading. So let's wait for around half a minute. Okay, so it is almost we have downloaded the data from this in the field format, and the size is around 50 MB. So our next job is to uh, read this data using Python code and plot the BPT diagram. So let's do it. Now we have data from the website, this Sky server SQL. So what I have done, I have changed the file name to bpt.feeds. Okay, and I will read this feeds file and extract the flux values. Okay, so for that I will use Python coding, and I will read the data from the feeds file. So for that I will import some libraries. So import library. So you can import feeds. So uh, from astropy.io import feeds. Okay, so this deals with the feeds file, and now I will read the BPT file. So I will give here file equal to uh, feeds dot open, and I will pass my file name. So I have bpt dot feeds file name. Okay, I will run it. So we have read the file successfully. You can see the file information by typing file dot info, right? So here you can see that your data is in your mm, first HDU, and it's a type table HDU, and it has dimension of uh, 500k rows and 8 columns. Okay, and format is 1e. Now, so we need to extract data from our first HDU, right? So I will type here data equal to file, and I will type here 1 for this number 1, and dot data, right? So uh, so this will like read the columns. Okay, the whole columns it will read. So if you type here, it will give everything, right? So you have to extract the every column individually. Okay, so what I will do here, I will extract each columns, or maybe you can also do one thing. You can also like print the what are the columns here, data dot columns. So you can see you have these column names, and you have to extract it. Okay, so I will extract columns. Okay, so I will extract first each alpha, H alpha equal to data, and I will give the square bracket as a string, and I will pass my this keyword. Okay, so it will directly uh, so it will, or maybe just type here H and press tab, it will automatically come in your notebook, so you can read it, so you can also check it. So here you can see this is your data. Okay, now you want to read your inch alpha, inch beta, right? You want to like, and you want to also like read the error in that. So inch alpha error equal to data and inch alpha flux error, right? This way I will extract every, I will go for inch beta, inch beta equal to data, inch beta, then error, now I will read O3, then error, then finally N2. And then read the error into error, right? Okay, so we have read the data. So now I will do some uh, data cleaning. Okay, so i will write here. So take only a flux having value. Okay, this value, I mean all fluxes should be positive, right? So this is the one case, and your flux ratio, flux or may just call it SNR. It's a signal to noise ratio. Your SNR equal to flux divided by flux error. So flux divided by flux error should be greater than 3. Okay, so we'll choose only values which are greater than 3 for each for your each um, mm, lines. Okay, now and then, okay, so here you can see that when you plot it the diagram, you have like log. Okay, so the log cannot be negative, so your into by h alpha should be positive, and also your O3 by h beta. So what I will do, I have into by h beta and O3 and O3 by h alpha, both should be greater than 0. Okay, so this will This will be like used to clean the data using these conditions. Okay, so let's do it. So now we are done with every conditions. Okay, so now we'll append these new data into a array. We'll be appending these new fluxes into a array. Okay, so for that I will define here empty array. Say h alpha new equal to empty matrix empty array, and I will give here condition each a new dot append equal to h alpha of I. Okay, so this will append the new values into the empty array. Okay, so here you can check it. What is this here? So it's still running because you have like used data sets. Okay, now check it. So you got here array. You can also you can check the length of that, right? So if you check the length of this and the previous one, you will see the difference. Okay, see you have like two different lengths. I mean, this means your data has been reduced. The length has been reduced. The column has been reduced. Now this much you have done. Now we'll like this will do for like your every. So here is beta new equal to, then here O3 new equal to, and then your into new equal to, and I will append. Okay, simply. So h beta new dot append equal to h beta I. Similarly you can append for O3 new dot append equal to O3 I, and same into new dot append equal to into I, right? So what is into new? There is a triple P, right? Now it's fine. Okay, so you got your fluxes. Now we'll plot it. Okay, so you can plot it. So I'll just give a comment here. Plot BPT diagram. So from the above fluxes. Okay, so we'll be now plotting this BPT diagram from these new fluxes. I will import matplotlib library. So import matplotlib dot pyplot as plt. So this is used to visualize data, right? Now I will plot it. So I have to plot this plot So we have x into by h alpha, right? So I will define here x, or maybe I can define here horizontal. Okay, horizontal equal to mm, you have your into by h alpha, right? So your into nu by h nu, right? And you can define your vertical equal to O3 nu by h nu, right? So what is the mistake? It's least. I think you need to make it a column. Okay, so make it a np dot array. See if it's working. Okay, so make it different. Yeah. So np dot array. np dot array np dot array. Yeah, now it's fine. Okay, so we got our x and y axis, right? Now plot it. So plt dot scatter and give here say horizontal, vertical. You can give some marker size equal to 0.1, and color you can give equal to red, and you can give here plt dot show and plot it. What is mistake? There is capital V and sorry, there's capital R and capital V. Yeah. Okay, so here you can see that this is the plot. Okay, but like you have to put the limits. So and one more thing, you have to take the log. Okay, so we need to take log. So I will type here np dot log 10, right? I will use equation for star forming galaxies, and I will use equation number 1, the condition 1, and for composite I will use equation number 5, okay, to distinguish between the AGN, composite, and star forming galaxies. Okay, so let's copy uh, the code, copy the lines equation. So let's do process, and I will add here. So I have to use equation equation number 1, equation number 1, and you have to use equation 2. You have to use equation 4 from here. Okay, so I will just so we have to plot these two equations in this our BPT plot. Okay, so in this plot we have to define this criteria. We will be plotting these criteria on this plot to make distinction between different galaxies. So I will put the first conditions. So I will define my say x1 I can define, and then I will define y1. Let's call it x and y. So y I can give say 0.61 divided by x minus 0.05, right? The second equation, and plus 1.3. Okay, so this should be less than this value. Okay, so I can give my, so you can see O3 by H beta. Okay, and into by H alpha. So I can give x range as, so you can see at 0.05. Okay, so there should be a bomb, I mean it's an infinite value, so we should give value below that. Okay, or we should exclude this value. So I can give x equal to np dot linear space. I can give from minus 2.52. Okay, so if I give say 2.5 to say 1 and plot it, see what happens. PLT dot x comma y, right? So there is PLT dot plot. So you plot, you can see there's at this point there's like an infinite line. So you have to exclude this line. So for that, just go little different. So 0.049, and here is the plot. Okay, for that okay. So you can similarly you can also define the another for this criteria that make difference between your composite and AGNs. So you can define your x1 and you can define your y1 equal to It's a 0.61 divided by it's a x x1 minus 0.47 plus 1.19, right? And then you can give your x equal to np dot linear space np dot linear space you can give from minus 2.52 or maybe you can give here, say you want to give here 100 data points also works, and 0 0.0 0.046 you can give here, and 100 data points, and you can plot it. So BPT dot plot x1 comma y1. Now see, you got here two plots, so maybe I can give some color. So I can give here c equal to black, and I can give here, okay, no problem, it will work. Okay, so we have done. So you can see this plot is similar to this plot I have shown you earlier. Okay, so I have opened the same plot, no differences, right? So I will mark these lines and labels to this plot. One more thing, here N2 by H alpha is your metallicity, because N2 is metal and H alpha is like your gas, and O3 by H alpha is your ionization. I mean, higher ionization is at top and higher metallicity is at the right. Okay, so now I will mark the labels. So I can type here label equal to SDSS, say Galaxies, SDSS data, and then you can give here label equal to, you can give this equation directly, and here you can give label equal to this equation, and you can type here purity dot legend, what is the mistake? Yeah, okay, so here you can see that got, I can show it. Now we have to mark our division. Okay, that left side is your star forming galaxy, this is your composite, and this is your AGNs. Okay, so I will type here plt dot text, and I can give my x position. So minus 1.521 minus 1.52 1.2, and you can give, say, AGN. So H2 regions. Okay, take some time to run. Okay, so this is H2 regions, so we need to go below. So it's minus 1.0. Okay, so it's a H2 region, And now similarly you can also mark, just give the coordinates, and so it's a 0 and minus 1.5. So 0 and then minus 1.5, call it composite. So composite, right? And you can make rotation. So rotation equal to 90 degree. So this is so vertically, and then you can add 4 AGNs. So it's 0.5, 0.5 and uh, 0.5 and 0.5. So 0.5 and 0.5. You can call it AGN. Now run it. So wait for some time. Okay, so here you can see that you have H2 regions, you have AGN, and you have composite galaxies. So this is like star forming galaxies. You can call it here star forming galaxies, right? Okay, so here you have final plot. So you have on x-axis we have density, y-axis we have ionization parameter, and you have this region is your H2 regions, means star forming galaxies. This region is your composite, which contains AGN and star forming galaxies, and this is your completely AGNs. So this way you can make your BPT diagram looks very convincing. So I hope you have got the idea that how we have done this uh, regressive plot on BPT diagnostic. So once again you can review the code what I have done. Okay, so this is a definition of this BPT plot. We have O3 by H beta and N2 by H alpha. So I have downloaded data from website, read the feeds file, uh, extracted the columns, and then I have given the condition for the data cleaning. For flux should be positive, SNR should be greater than 3, and log of this flux would not be negative ratio. This is condition, and then I've got new data plotted, and then I've given the criteria to distinguish. So this is my final result. You can see here. So I hope you got the idea. Thank you.